So the question is based on nuclear physics or radioactivity. The subtopic is radioactive decay. So it was in Science Paper 1 2021, question 20, A20. Strontium-90 undergoes a beta decay to produce element Y. Which of the following shows the decay equation? So we have 4 equations here. Now to answer this question, let's pick out the 3 things we need. So first, we are going to pick out strontium-90 with this nuclide notation, this one here. Then we also pick beta particle, you see. So the beta particle has this notation, electron, then 1 at the bottom, then 1 a 0 on top, then Y. So what has happened is strontium has decayed to form a new element Y. In the process of decaying, it has released this particle, beta particle. Now, before I answer, you must know that when a radioactive element decays, it releases particles. Those particles can be an alpha particle or a beta particle or gamma ray. So an alpha particle has this nuclide notation of helium. Then beta particle is this one I've written here with this notation. Then the gamma ray, we just write using the Greek letter that looks like Y. Okay, so I'll explain this. So now, what happens to the element that decays depends on what kind of a particle that it has released after decaying. So in our question, it is a beta particle that it has released. So decay simply involves what happens to its mass number, that's the radioactive element, the mass number, and what happens to the atomic number as well. So if it is a beta particle like in our question, the mass number does not change. That's why we have 0 here. So it remains 90. Then the atomic number increases by 1. That's why we have 1 there. So it increases by 1. So element Y will look like this. Therefore, the full equation is strontium-90 decays producing element Y, 90, then 39. You see the difference under here? Good. Then plus, you write the beta particle. This is a beta particle, showing that it has released a beta particle. So this is the full equation. Okay? Therefore, the answer was C. That's the end of the question. Now, if it released an alpha particle, the answer would have been different. And if it released a gamma ray, it would have been different. If it was an alpha particle, this mass number here could have reduced by 4. And also, the atomic number would have reduced by 2. So an alpha particle reduces the mass number as well as the atomic number. The beta particle, only the atomic number changes and it involves gaining. Okay, it gains. Then for the gamma ray, neither the mass number nor the atomic number changes, so no changes. So I've just given these additional points in case if it was an alpha particle mentioned instead of beta, or if it was gamma. This is the way you would have handled it. If you like the video, come back for more.